This video is going to look at three more trig examples, and this is going to review a little bit of evaluating our different trig functions that we talked about in the past. So here we are given the cosine of an angle theta is equal to 8 over 17. And then they also tell us that tangent of theta is less than 0. And really what that means as well, if tangent theta is less than 0, that means that the tangent of the angle is going to be negative. And they want us to find the sine of an angle. So using the given information, the cosine and the tangent is less than 0, let's see if we can go about locating that particular angle. Well, first of all, if we know the cosine is equal to 8 over 17, our cosine function is really x over r. So what that means is, where can we draw our triangle? Well, we need to keep in mind, first of all, x, if that's 8, then that means we're going to be going out 8 on the positive x-axis. Well, that means that we could possibly draw our right triangle here, or we could draw the right triangle down here. Now, we need to keep in mind that 8 is positive, so therefore it's got to be in the first or fourth quadrant. If 8 was negative, then that means we'd be going over here to the left. And we notice 17 is positive. Well, the radius, or this r value, if you think of the circle, that's the radius or the hypotenuse. Keep in mind this r value here is going to be always positive because this is always going to be a positive value. The only value that can be negative would be the x or your y value because x is going left to right, y is going up and down, but the r value is always going to be positive. So based on the cosine is 8 over 17, then we could certainly draw our right triangle here because we don't know if y is positive going up or if y is negative going down, because this side, which is the hypotenuse or the r value, is going to be 17. Now, because they tell us that the tangent is less than 0, because we know this, the tangent, remember, is y over x. Well, in order for this to be negative, that means that your y and x have to be opposite signs. In the first quadrant, y and x are both positive, so therefore that would eliminate the first quadrant. So that means that our angle we're talking about here that goes all the way around, this angle must be in the fourth quadrant because there you have a positive x, and we know that we're going down, so therefore the y value must be negative. So then how do we find the other side? Well, of course, we can use the Pythagorean theorem. So we know that x is 8, so we would take 8 squared plus y squared equals the hypotenuse or the radius squared, so that's 17 squared. So we would get 64 plus y squared equals, and then 17 squared is equal to 289. So that means y squared is equal to 289 minus the 64, which is 225. Now notice what happens here. We have to take the square root just like before, and we could get plus or minus, and the square root of 225 is equal to 15. Now, is it going to be positive or negative? Well, in this case, looking at the diagram over here, we already said we're in the fourth quadrant, so that means we have to have a negative 15 because here the y value is going down. Once again, if this tangent wasn't less than 0, then if it was greater than 0, that means we would have drawn the right triangle up here, and then the 15 would have been positive. So therefore, in order for it to fit in the fourth quadrant, we have to choose the negative to make it a negative 15. All right, so now that we have our triangle here, and once again, we can think of this angle here kind of as our reference angle. So I mean, if you want to think of this as the angle, but the true angle is theta going all the way around. But now we have our little right triangle, and we want to find what is the sine of theta. Well, remember, sine of theta is equal to y over r, or again, if you prefer, you could think of this as opposite over hypotenuse. So either case down here, that would be a negative 15 over 17. And of course, this was only asking for the sine function. We could find all of the other trig functions just based off of this particular right triangle. Okay, the main thing you want to learn from this is if you're given the cosine and this tangent less than 0, can you draw your right triangle in the correct quadrant so that you can solve the triangle so that we have all three sides, and then you can identify any trig function that is needed. So now if we look at the next example here, and this one you may want to try on your own, so you can pause the video and see if you can work this one out. This time we're given the sine of theta is equal to 3/5, and now they tell us the constraint here is the angle theta is actually in quadrant 2, and we're looking for the secant of theta. So if we look at this here, we know that if we draw the triangle from this constraint, they tell us we're in the second quadrant. Now, let's just look at the sine function to see why this part is important to know. Because the sine function is y over r. We know the y value is a positive 3. So what that really means is that we could certainly draw our triangle going up 3. So basically what that means is our right triangle could be here or it could be over here. And that's because if we label this as 3, we know this is 5. What we don't know is whether the x is positive or negative. So without the constraint here that theta is in the second quadrant, we cannot determine which quadrant that we're in. So that's why they always have to give you a constraint. And then if we go up here, the previous example, they told us the tangent was less than 0, so therefore it narrows it down to only one quadrant. So for this one, that means we can eliminate here, and we know that the y value is a positive 3. We know the r value is always positive, so that is 5. And then if we want to find the x, again, I would go ahead and mention this. We know it's got to be negative because it's going to the left. So therefore, if we use x squared plus 3 squared equals 5 squared, we get x squared plus 9 equals 25. So therefore, x squared is equal to 25 minus 9, which is 16. So that means we would get the square root of 16. And keep in mind that means it would be plus or minus. And we already know that it's got to be a negative because we're going to the left. So therefore we have a negative 4. Okay, so now that we have, once again, this is our angle, but for all intents and purposes here, we can think of this as the little reference angle here as the right triangle. And if we're looking for the secant, then here the secant of theta, do we recall what that means? Well, the secant is the reciprocal of our cosine, and our cosine function is x over r, so that means this would be r over x, so therefore we would take 5 over negative 4 would be the secant. Okay, then we have our last example, and once again, maybe you want to attempt this one on your own. This case, we are given the cosecant of theta equals 4. They tell us the cotangent is less than 0, and we want to find the cosine of theta. So once again, we want to determine which quadrant are we going to be located. So if we think of the cosecant, it may be helpful to think of this cosecant as 4, so we can think of that as 4 over 1. And the cosecant is the reciprocal of sine. Sine is y over r, so that means this is r over y. And because, once again, the y value is 1, which is positive, we know that the right triangle has to be in the first quadrant or in the second quadrant. So then if we go over to the cotangent is less than 0, which means it's negative, and cotangent is the reciprocal for tangent. So therefore the cotangent is x over y. And really all we're concerned with is if this is going to be negative, that means that x and y have to be opposite signs. So that's going to happen over here in the second quadrant because in the first quadrant they're all positive. So we know that our right triangle is in the second quadrant. So that means the angle is theta is located here. And once again, we can really think of this little angle here as kind of our reference. So that means r is 4, y is 1, and once again we have to solve for x. So we would just go to the x squared plus 1 squared equals 4 squared. So x squared plus 1 equals 16. X squared is equal to 15. And once again, when we take the square root, it's plus or minus. And you determine, is it going to be positive or negative square root of 15? Well, once again, if we look at the picture, we know we're going to the left, so it has to be a negative square root of 15. So now that we have our right triangle, we can then certainly determine the cosine. The cosine of an angle is x over r. So that means in this case, the cosine is going to be negative square root of 15 divided by the radius or the hypotenuse, which is 4. Okay, so keep in mind here, it's very important to realize for these 3 examples, and if you have to, go back and watch the video again, but realize that it's important that you draw the right triangle in the correct quadrant. And usually you're going to have to be given some kind of a constraint so that you can narrow it down to the exact location. So in this case, they gave us the cotangent. The previous example, they told us it was in the second quadrant. And in the first example, they told us the tangent had to be negative.